Today we'll talk about lights in 3D. You will learn what kind of light sources there are, when to use them, and their settings. Let's start with the types of light sources. There aren't many, but they allow you to create any lighting. Which to use depends on your project purpose, but I will tell you about main uses for each of them. So let's begin. Ambient light. This light source illuminates your scene from all sides, as if you were in a huge glowing sphere. It can be used to make shadows less deep or create completely uniform lighting. Directional light. This type of light simulates the way the sun works. It's a light source that's very far away and relatively small, but very bright. It illuminates the entire scene and creates hard shadows. But it's not often used, because it doesn't allow you to accurately simulate the sun. And the source that lights the whole scene and creates hard shadows is rarely needed. Instead, more advanced systems are used, such as the V-Ray Sun, which has significantly more parameters and simulates the real behavior of a sun, depending on its location, size, atmosphere, and so on. Point light. It's a type of light that emits from a single point in all directions. It's often used to simulate light bulbs on small light sources. Spotlight. It's a type of light that emits in a specific direction and illuminates a small area. It's often used to highlight a specific object or area, or to restrict light source. Area light. It's a type of light that casts from a rectangular or circular shape. It's often used to simulate large light sources such as softboxes or windows. Sphere light. This light source has a sphere shape and illuminates in all directions. It's used to create soft shadows and to simulate spherical light sources. It's like a point light, but with additional control. Dome light. This light source is similar to ambient light, but it has more control. For example, here you can set the environment that will illuminate the scene. Typically, this light source is used to create any scene that has an exterior or light from it. Mesh light. In this case, you can turn any 3D model into a light source. This is done by assigning to it a material that emits light. It's used when you want to give a specific shape or volume to the light source. IES lights. IES stands for Illumination Engineering Society, and an IES light is a type of light source that uses an IES file to define its shape and intensity. IES files are created by measuring the light output of a real light source, and they can be used to create very realistic lighting. Sun and sky. Also, in some render engines there is a sky. It works in conjunction with the sun and creates a complex and realistic lighting system that simulates the real sun and atmosphere. These were all types of light sources in 3D. However, there may be other variations in some programs. But this should be enough for all of your projects. But now let's talk about settings of these light sources. I'll start with the common settings, and then I'll talk about more specific ones that only certain light sources have. Let's begin. First, you need to decide what units of measure is used to regulate brightness. There are several to choose from. Image, where the color and multiplier of light source determines the light intensity. Luminous power. It's total emitted light measured in lumens. When this setting is used, the intensity of light doesn't depend on its size. And for example, a typical 100 incandescent light bulb emits about 1500 lumens of light. Luminance. It's power measured in lumens per square meter per steradian. When this setting is used, the intensity of light depends on its size. Radiant power. Total emitted visible light power measured in watts. When using this setting, the intensity of light doesn't depend on its size. Keep in mind that it's not the same as electric power consumed by a light bulb, for example. A typical 100 light bulb only emits between 2 or 3 watts as visible light. And radiance. It's power measured in watts per square meter per steradian, and the intensity of light depends on its size. And the next common setting for lights, it's whether the light source is visible or invisible in the scene. And not if it's invisible, it still emits light. You can also specify the color or temperature of a light source. While the color is easy to understand, the temperature corresponds to how light bulbs indicate whether they have a warm light or a cool light, and it's measured in Kelvin. The lower the Kelvin temperature, the warmer the light appears, and the higher the Kelvin temperature, the cooler the light appears. Another setting that you can of course change the size of a light source. This will affect how soft or hard shadows appear in the scene, and it can affect brightness depending on which units of measure you choose. Besides, you can control which aspects of 3D models are affected by a light source. You can turn off shadows or have no effect on diffuse or reflection or specular or atmosphere. And you also can exclude certain models from being affected by the light source. Now let's move on to parameters that not all light sources have. Two-sided. This parameter allows you to make light source emit from both sides. For example, plane will emit not on one side, but on both sides. Sun and sky. If your render engine has a sky and sun system, they will have many specific parameters. I won't go into details, but they should be clear from their names, such as how high the horizon is, whether the clouds in the sky, what size of a sun, and so on. Direction. Light sources such as area light or spotlight have ability to adjust the direction of light. This option allows you to direct the light similar to how spotlight does it. HDRI. Dome light has ability to connect the HDRI map, which allows you to simulate realistic lighting of a real location. In addition to being able to connect the HDRI map, you will also have the ability to control it. For example, rotate horizontally and vertically or change intensity. And if you want to know more about HDRIs, I have a video about them. Maps. You can connect maps to some light sources. For example, you can do this with plain light. A map allows you to give the light source a more specific shape. For example, you can set a gradient on it that will simulate an object blocking the light source. Decay. The decay parameter determines how the light fades in and out. This allows you to manually set the light behavior depending on the distance from the light source. And that's also all the settings that light sources have. However, depending on the render engine and program, they may be called differently. Nevertheless, these settings and knowledge are enough to illuminate anything and any way you want. And lastly, I would like to say that the program you are working in probably has a way to conveniently control all the light sources. Often they are represented by a list where you can quickly change basic parameters or turn lights on and off. Also, additional control over the light sources can be achieved after rendering. Render passes can be used for this. Or additional features of your render engine, like in V-Ray, where you can control and adjust light sources after rendering the image. And that will be it. Thanks for watching, hit like and subscribe, and I wish you good lighting.